Welcome everyone. This is take 2 of our recording of the Tuesday night, March 29th iOS class. Unfortunately, QuickTime kind of decided to abruptly end Tuesday night, so this is take 2 of the recording for that night. What we are covering, or what we did cover in class, was we had left off before break with the drawing application, or handy dandy sweet little drawing app where we could draw circles, and we could draw squares, we could draw little dots that we made to be lines, and then we could erase it. So that was the essence of our drawing app. It's pretty cool, but we were lacking one significant thing, and that is object persistence. So we couldn't save our drawing or load a saved drawing or anything like that. So what we did Tuesday night was we added that functionality. And so tonight, in a somewhat abbreviated fashion, I'm going to duplicate what we did Tuesday night. So I'm going to go ahead in my simulator here. I'm going to go to home, and put this back at home. And then I'm going to go, first thing we want to do is we want to have code in our draw view. So our draw view is the view responsible for drawing all the shapes. The shape object is the actual circle, square, dot. That's the object that draws itself. It has knowledge of how to draw itself. Then its parent view is the view that handles touch events and then adds these shapes to itself, to its view, and then tells its parent, the view controller, hey, we have a new shape, add it to the list of shapes. So the views are the ones that do the drawing and manipulate the objects, and the view controller is the one that handles the data and keeps track of lists of data and stuff like that. So the first thing we did in the class is we created a function that we call draw saved shapes. And this guy simply got the data from the parent, got the shapes from the parent. Got the delegates shapes using the protocol method get shapes. That gives us an array of shape objects. Then we had a little loop that just loops through all those shapes. And my laptop is sounding like it's about to take off here, so hopefully we don't have an issue. And this guy's got needs an exclamation point in him. That cleans that up. In here, we're going to create shape objects and add them to our view. So basically, we're doing the same thing that happens in our touches began and touches moved, but we're going to get our shapes from a saved file that's on disk, and we're going to load them, and then we're going to draw them back into the view once they're loaded. And this guy is going to need an exclamation point too. Let s equal shapes I, and then the only thing we have to do is set the background color to be clear. And then we add it to ourselves. We say self.add subview, and we pass an s, and life is good. I'm going to do a build. Build succeeds. So this is the code that we're going to use. I'm going to put a comment in here. Code, caps, code to draw saved shapes. Okay, dandy. So that's the first thing you got to do. Next thing we're going to do is we're going to add a variable to in our draw view. We're not going to add a variable necessarily, but what we're going to do, actually I think we are, in the shape class. No, I have a start point already defined in the shape class. So that start point, although we don't really use it much really currently in the drawing code, we are going to use that for our saving code when we want to save our shapes off, because Objective-C and Swift do not support the saving of custom objects. So, like, we can't just take our shapes and serialize them out and save them to disk. That won't work. So in Objective-C and Swift, you have to have a primitive type being an NS string, an NS number, NS array, or an NS dictionary. You can't save your own custom class. Objective-C and Swift are kind of old-fashioned that way. iOS is kind of lagging behind. For example, C# and Java have the ability to serialize into JSON custom classes. Swift and Objective-C both lack that ability. So we have to convert all of our stuff to dictionaries and stuff. So we can't save the shape class, and we can't even save the shape types because it's an enumeration, which is a custom type. But what we can do is we can take the start point of our object, so that when we tap or we move, or when we tap to make the object, or when we start moving, we can capture that start point, and that start point will be where we're going to redraw our circle or our square or our dot when we load it back off of disk. So we want to make sure that in our code here, when our touches began and our touches moved, that we set that start point. And it looks like I have that code, and I even have a little comment. So I forgot to take this out of the finished product. But the start point we set here, we get the point where the touches began right here, using the touch.location in view. That gives us a CG point, and then from the CG point we take that and we set the shape's start point to be that point, and then I also do it in the touches moved because we create a new shape in the touches moved as well. Set the start point to be that new point. So that piece of coding is done. So we've captured the start point. So we're going to take that start point, we're going to serialize that, we're going to take the shape type, convert the shape type, which again is an enumerated type, convert that to an integer so we can save that as well. And then we'll have the components that we need to serialize to disk and to load from disk. So the next thing we need to do is in our view controller. This is where a lot of the action is going to happen from here on out, is in the view controller. It's going to be the brains behind saving and loading and doing all that stuff, managing the objects. So in here, we're going to need to create a function called create data for drawing, because when we write data out to local storage on a device, we can't just write it out as just plain text. We have to convert it to what's called NS data. All the contents on a device, on an iOS device, are encrypted, and so we have to format our object in such a way, serialize it in such a way that iOS can encrypt it and decrypt it, and so that format is an NS data, which is kind of like bytecode, kind of like an array of bytes or characters like you would use in Java or C#. So we're going to create a function in the view controller, not with all caps on, func create data for drawing. Okay, and this guy is going to produce for us an NS data, which is basically like a blob of bytes, or serialized like bytecode. So we're going to create a variable called saved shapes. And this is going to be an array, an array of NS mutable dictionaries. So as I mentioned, the basic primitive types are the types that you can serialize. One of them is a dictionary, or a mutable dictionary will also work. An NS mutable dictionary, an NS dictionary. The other type is an NS array, NS strings. So we're going to create an array of dictionaries. So the dictionary is going to consist of the shape types, and it's also going to consist of the start point. All right, so first thing we need, before we go any further with this, I just realized we're going to have some code to actually convert our object, our shape object, into something that can be used for storing. So we have to convert our shape object, which is a custom type, into an NS dictionary. So in order to do that, what I'm going to do is we're going to create a function called convert data for drawing, or convert to dictionary. And we're going to put that in the shape object. Just a second here, and I'll pull up the code for doing that. Bear with me for just a minute. Okay, so what I need is to create a function in our shape class that is going to allow us to convert everything into an NS dictionary. So we'll go into our shape class. And a message popped up there, sorry about that. Okay, so I go into the shape class. And it looks like actually I forgot to remove this code too. So my bad, that's already here. So in the shape class, I created this method called convert to dictionary. This creates an NS mutable dictionary. So what this code does is it creates an NS mutable dictionary from a method, from a constructor method that you pass in an array of objects. And what I did was I took the start point, which was set in the touches began or the touches moved event, to the touch that was in the view, sets the objects in this NS mutable dictionary to be the start point.x and start point.y values. So those are primitives, so it can handle that. So those are the values in the mutable dictionary, and the keys are start x and start y. The last piece of information that we store in this dictionary is the shape type, but we can't use the shape type, like I said, because it's an enumerated value, and that's a custom type. But what we can do is take the shape type's hash value, and the hash value converts the enumeration into its raw integer value. And then these are the keys: start x, start y, and type. Those are the keys that we're going to use to store the values in this dictionary, and then we just return the dictionary. So that is the method that we're going to call from the parent, from the view controller, to save off the dictionary. So the shape type converts itself into this dictionary, and then from there it can be serialized into disk. Okay, so going back to the view controller class, we have our save shapes, which is the NS mutable dictionary. We set that equal to an empty array, and I do this right off the bat because if we didn't save anything and we don't initialize this to an empty set, it's basically null, and then that can cause a crashing situation. So I make sure to initialize that to an empty array, and then after that we're going to create one of these guys. We're going to create a variable. I called it JSON data. This is an instance of NS data, which is our actual bytecode that we're going to save to disk. And then again, we're going to loop through our shapes. Just like that. And in here we're going to say let s equal shapes I, and I'm going to just, yeah, that's fine. I can just say that. And we're getting a lot of fan action here again. I'm not sure why. I think it might be because QuickTime's running at the same time. So not going to mess with QuickTime because I don't want it to crash. But anyway, now what I'm going to do is I'm going to create a dictionary, let D, because I'm a lazy typist, d equals shape dot convert to dictionary, which is the method I just showed you, as ns dictionary. And I got to put an exclamation point here. Maybe not. Okay, so this creates the dictionary, and then I'm going to append my dictionary to my saved shapes mutable dictionary right there. And then that's it for the for loop. Except it doesn't like something about it. Cannot convert value of NS dictionary to expected argument of this. Okay. Oh, this needs to be a mutable dictionary, not a. Because we're adding objects to it, we're mutating it. All right. So that's all good. We got an error here because we're not turning anything yet. We'll fix that in a moment. Now, here comes the tricky part. So we have to create our data. We can't just write a dictionary out to disk. We have to convert it into data in order to be able to actually write it to the local storage on the device. So there is a error trapping mechanism that came out with Swift 2. This is really recent. You're familiar with the do while loop, probably. Well, this is a different use of the keyword do. Instead of do while, you do a do try, and then at the end of this, you have a catch handler in case there is an error. And we have some kind of weird looking syntax going on. I'll explain this here in a minute. We catch an NS error object. All right, so in the do, we have, this is the try portion, which you might be accustomed to seeing, try catches and stuff with like C#. So we're going to make, and here's the actual meat of what we're doing. We're calling NS JSON serialization data with JSON object. So this is actually what's doing the work. This JSON serialization is converting our data into a JSON object. So the saved shapes, this is our array of dictionaries, is what we're converting into NS data. And the second parameter to this function is the NS JSON writing options. Writing options. And we want it to be, the option we're going to use is pretty printed. Really kind of funny term. It just means that it will look good. It's readable when we pull it out. We can actually, it has, instead of just being a blob of text, you can actually, it has formatting applied to it. If this doesn't work, you're going to print the error. And that's all there is to that. And then the last thing is we're going to return the JSON object. All right. So that is our method that we use for converting our shapes into dictionaries, and then from an array of dictionaries we convert that into NS data, and then the NS data is what we actually write out to local storage. All right, so we've got a few things done now. We can draw the objects once they're loaded from storage, and we have a means of serializing the data, which then can be written to disk. The next thing we need to do is actually perform the action of writing it out to local storage. So for this, I'm going to create a method called simply save drawing. And the save drawing is what's going to get called when we are done. We tap on the little like save icon, and it's going to do this part. So first we call create data for drawing, which is the method we just made. That gets us our data. So all that work we just did, all that does is give us the data that we're going to use for writing. Now the next thing we need to do is find our path on our device to our local documents folder, which exists on the phone, local documents directory, which is our local storage. And for that we use a class called the NS File Manager. And I'm going to create an instance of that. So file manager equal NS File Manager default manager. That gets us the default file manager. Then we say let path equals NS search path search path for directories in domains. Big long name, relatively simple function. All it's doing is it's looking in a specific area to find a search path. And again, sorry, I got the messages popping up there. All right, so in a search path for directories in domains, this allows you to search in various directories such as local user directory, applications folder, document directory, and that's the one we want. We want the document directory. The domain mask is going to be the user domain, not system domain. There's various domains. We want the user domain mask, which is the currently logged in user, and then we're going to use true for expand tilde, which means you've seen where you have the tilde operator that gives you relative paths. We want to expand that. This gives you an array of paths. You just want the first one. Okay, so that gives us the path basically on the device to our documents folder. Then once we have that, it's a little bit convoluted, but bear with me. We're going to create, actually go back up here, an NSURL object. NSURL is a handy little guy. We use it for the web view that we created before. We're going to use again, this time we're going to create a URL calling the file URL with path. And the path is the one that we just created above. The reason why we do this is because creating a simple file path doesn't format it in a way such that the file manager can easily read and write to it. We need to use the URL objects to decorate the path with things like the file, whether it's a file, a URI, a resource, so it has the knowledge to format it correctly so that it can be read from and written to. So we create our URL, and then we're going to append our URL with the name of our JSON document that we're creating from our objects. So the last step is going to be that looks right, except for the fact that it's the case. File path, I'm sorry, URL path, rather, URL path.url by appending path component. So what this does is it creates the fully qualified URL path in local storage by appending the word drawing, this is what we're going to call our file, drawing.json to the end of it. So that creates the necessary path components such as the backslashes, all that good stuff. Then, now that we finally have our path constructed, next thing we do is say if file manager file exists at path. So we want to check to make sure that, to see if it's there first. And the path is file path dot path. Gets the string component back out of it. Seems like a lot of work, but it works correctly. All right, with the exclamation point. Then we're going to say put file available. Otherwise, it's not available. We need to create it. So this is the case where the file does exist. This is the case where we have to create the file. Okay, so in this instance, what we're going to do is say file manager dot create file path, and the file path, of course, is our file path dot path again. Contents are data we created, and the attributes are nil. We don't need any attributes. Just going to write it out in raw form. That actually creates the file for us. And then once the file is created, then the next thing we want to do is say, using NS, called NS file handle. NS file handle for updating that path. So we're going to update our file. And we'll say if, fix this here first. I think what we need is this. Alright, that takes care of that problem. So create the file. If the file is equal to nil, so we had a problem creating our file, then we're just going to print out a message saying that file creation failed. Else, we're going to do our writing. File seek to begin seek to file offset rather file offset 0, beginning of the file. File write data, data, and then file close file. And that takes care of saving off our file. Fair amount of work, but in the end it works out for us. Okay, so the next thing we need to do, now that we have that, is in our view controller at the top, in the view above, we need to create a button to save this guy. So up here, I'm going to copy this code. And by the way, I added an icon to the project, floppy icon. It's our save icon. And so that's going to be on our toolbar. So I'm going to create that. Button 5. And button 5, we'll replace 4 with 5 everywhere. Replace eraser with floppy. And the action is going to be our method here, save drawing. And button 5. And bar button item 5. Bar button item 5 again. And button 5 here. And with that we have the making of our save stuff. Alright, so I think we have everything we need in place now. We have our dictionary code, go from the dictionary array to NS data. We create up here and create data for drawing. Then once we have our data created, we call that method, and we create a file manager and we write it all out to local storage. So let's see how all this works. If we've done everything right, this should run like a charm, right? There we go. Okay, so there's our save icon. So I'm going to create some circles, some squares, and save it. And something went wrong. I did something incorrectly. I expected to find nil and unwrap an optional value. So let's see where that guy is coming from. It's coming from our create data for drawing. If we go in here, create data for drawing, and JSON data is nil. And let's see. Oh, Yeah, I don't believe I ever set it equal to anything, actually. That would account for why it's nil. This guy needs to be in here. This needs to be set equal to this. And without that critical little piece, it's going to be nil. So we're going to stop it and rerun it. See how it works out. Now, this time that we actually have an assignment operator there. Okay. And I'm making this a figure 8. Some squares in there and save it. And it crashed again. And then it crashed this time. Concrete file handle write data. Okay, so here's my error. I may not be able to get into the call stack this time. It looks like I lost the call stack. So what we're going to want to do, rerun this and see what's causing our little faux pas here. Okay, we're going to the save drawing. We'll try this again and see why it's dying. It's because it's dying pretty hard and fast. Okay. Circles, squares, save. Okay. Data comes back, 7,461 bytes. We're done that, looks fine. File manager. I think we had a successful creation. Path, you can see the path right down here, so it has the file path. URL path is okay. And we check to see if it exists. Okay, it says it does exist, so it's already there. And create a file. File's not nil. We seek to the beginning. We write the data, and that's where it doesn't like it, is in the writing of the data. So we have to figure out why that is, why it doesn't like the writing of the data. Obviously doing something wrong there. So what we'll have to do in this case is we'll have to go into our view controller and see why it's dying like that. So let's go back to the view controller. Let's see. Oh wait, that's probably why we're there. Critical little typo that's causing us some undue problems here. So instead of reading, what we need to do is change to updating. We're updating that. Alright, for updating the path. Let's try that. Getting a little sloppy here because I'm trying to do this quickly. So I'll try it again. See if we have some better success this time. I should get it to successfully write maybe. Alright, so there's a breakpoint. I'll go through this. See if this time it will allow me to write. Yeah, so managed to step through it. Everything looks like it succeeded, so we should now have a file at that path. Okay, so in the interest of expediting this a little bit, because I think my computer is really ready to take off here, judging by the sound of the fan, I think it's having QuickTime running, creating this ginormous recording while I'm compiling, building, and running, I think is causing it to kind of stress. So what I'm going to do is I have the finished code handy. We have the save portion essentially complete. The next thing we need to do is the loading from local storage. That part also happens in the view controller class. So what we're going to do is there's a few functions that I created to allow us to reload the content that we saved off the disk. Kind of the reverse of what we just did. So the first one was load contents of saved drawing. I'm going to go ahead and copy the finished code that I have, and then I'll just talk my way through it again in the interest of time and making sure that this time the recording is saved and it doesn't crash. Alright, so here's load contents of saved drawing, and this creates an array dictionary objects. Remember, that's what we created before we wrote to local storage. We had to create an array of dictionary items. It has to be a primitive type, which an NS dictionary is, so it's an NS array. So that's essentially what these shapes are, just a big array of dictionaries. So a dictionary is an aggregation of primitive types, and that's what this is. So we load the contents of the saved drawing. So what it does is it does a reverse process. It creates a file manager. Again, this is identically the same code as what we had above, or below rather. It's this block of code right here, for the most part. Creates a file manager, looks in the search paths, looking in the document directory. Same as we did before, we create this path. We append the name of the file that we created to the path. Then we create an instance of a NS data type. And then we have this other variable here I created, which is an array of NS dictionaries. This is the decoded data. So first we read the raw data out, then we decode it into an array of NS dictionaries. So again, the file manager checks for the existence of the file in the path. If it's there, it loads it up using contents at path. So a very simple method call with contents at path, loads up the contents of the file into an NS data. Then the next thing we do is we have another one of these do catches, these do try catches, that wraps the call to the JSON object with data. So this is the reverse of serializing. This is deserializing. It creates it creates an array of dictionaries by deserializing the data. And then we typecast it as an array of NS dictionaries at the end. That hopefully will give us our decoded array of dictionaries. And then we will return that. So that's what comes out of that. Then the other thing we want to do is, once we have an array of dictionaries, that's not what we want to go or save in our class long term, because what we actually want to end up with is an array of shapes, not NS dictionary, because we have a custom drawing class that we made. So the next thing I did was I created a handy little kind of utility method called load objects back up, and we will put that guy right after the load contents of saved drawing. Here, paste this in. Load objects back up. So this takes the output of our load contents of saved drawing, array of dictionaries. That's the input into this guy. And in here, all it does is it loops through the array of dictionaries and basically rehydrates or recreates the shape objects. Creates a point from the serialized start x and start y, which are the keys to our x and y coordinates that we saved off in our dictionary. Has a variable instance of cgrect, and then it pulls out the type of the object. So again, those are saved. That was saved off as an integer. We used the hash value of the shape type to just save off raw integers so that it conforms to the primitive type. And then we do a switch to check what that type is. 0 was a circle, 1 was a square, 2 is a dot. And then we create rectangle objects, which are basically the frame, the bounding frame of our object. If it is this should actually be, I think, 13 because these were 26. 26 by 26. I'm going to fix that. Same thing with the square. So the midpoint is 13 pixels in, 15 pixels in, 26 by 26 overall. And then if there's a point or a dot, there are 4 pixels total. So what we're doing is recreating the frames. Once we have the rectangle for the bounding frame created, we set that using the init of the shape object. So if we go back into shape, here is our init method. I'm sorry, that's our draw rectangle. So in our init, it's down here, we pass in a frame, and that establishes the size, the bounds of our shape class. That's what we do there. We're going to set the shape type equal to the type that corresponds with the integer value. And then at the end, we append that shape to the end of our shapes array. And then basically we've pulled the shapes back out and put them back where they started from. Okay, so that's about all there is to that. So once we have our shapes back, then we can call the views draw saved shapes. That was the first thing that we did. Right here, we draw saved shapes, and then we can draw them. So that will be what we'll do in our view did load. After we construct our toolbar buttons, we'll check to see if in fact we have that file saved off, and then we'll go ahead and load up the saved shapes. So when the user comes into the app, boom, there they are. So we can say we have an array which we get from load contents or saved drawing. This creates our dictionary, our array of NS dictionaries. Then we call the load objects back up, passing in that array of dictionaries. And then we get a handle to our draw view. And we need to put an exclamation point in there. Okay. Then we just call draw view.draw save shapes, and that draws them. And that should be everything we need to do. We have our checking in our load contents. So if there are no contents in the file, in other words, they don't have a file, this basically is an empty array, and nothing gets loaded or drawn. Otherwise, if there are saved contents, then it goes ahead and loads them up and draws them for us. All right, so let's go ahead and run this. And we had saved contents, you'll recall. So that got loaded up. So everything worked correctly as intended. So if I add, say for example, a line object up here at the top, I'll just have this circumnavigate the whole thing like that. Let's save it. Just have a breakpoint in here. I'll delete that. Okay, so hopefully that's saved, and then we stop it. And then we run it. And there it is. There is our line going around. One more thing we will need to add to our clear, to our eraser. If we clear out the objects, we want them to be completely removed from the view, but also we want to remove everything from the file. So that, for example, if we delete or we erase our drawing and then close the app, when we come back in, we don't expect to see the drawing recreated because we erased it. So one more thing we'll want to do in our clear method. There he is. There's our clear method. We remove all the shapes, as you can see. But we also are going to want to call our, actually, we're going to have to call something I haven't created yet. So the last piece of this, which I have not coded yet, and so I'm going to borrow the code to show you rather than typing it all out in painstaking detail, is the removal of the file. So thus far we have read a file from local storage, write a file to local storage, and now the final piece is deleting a file from local storage. Oh, the fun we're having with files. Okay, so here we go. remove file. So first part of this method is identical to the other two file manipulation methods. We get a file manager, find the path, create a URL, append the file name to that, so that part is identical. Done it already twice. Then this part, the do try catch, is all very similar as well, only this time instead of reading or writing, we're removing item at path. So that's how we remove the file. And this catches the error as well. And we'll just print out the error.description if it fails. And then the last thing we do is call self.shapes.removeAll. Alright, so in here, in our clear here, you don't need to call self.shapes.removeAll because remove file does that for us. So just call remove file in our clear method, and that should delete the file and all of its contents. So basically we're starting from scratch. We're just completely removing that file, and then we'll recreate it when we need to. Alright, so try that. Okay, so there it is, and we'll go ahead and clear it. Okay, so that should have deleted not only the contents of the drawing from the view, it should have also removed the file. In fact, what we can do is we can stop it and restart it just to make sure that that is in fact the case. Yep, it's clear. Got a clean sheet to start with. So we can start creating our next drawing. Like a little robot guy here. Smiley face. Alright, save that. Save it again just to be sure. And close it or stop it. And we'll rerun it. And there he is. Now we can add to it. Get our fine fellow here. I'm not an artist, and especially not a iOS simulator artist. But there's that. Let's save them. I'll stop it and rerun it. And there he is, all modded up with his spiffy hairdo and stuff, his smile. So this is pretty comprehensive as far as drawing app. I mean, not in terms of like an actual commercial drawing app, but it gives you the basic functionality to do most everything you do in a commercial app. It just doesn't have all the full featured functionality, but has the basic stuff. The one thing that you would want to add to this right away, which I probably will, that's like a hint. By right away I mean as an assignment. We'll want to add a button to allow the user to load from disk on demand, so they can load up their saved drawing without having to stop the app and restart it to do it. So that's something that you'd want the user to be able to do. So that basically is what we covered in class Tuesday night in a kind of nutshell fashion. And I'm going to go ahead and stop this recording now while it still exists, and then I'll upload it, and then go about the work of creating an assignment for you guys. So thanks for watching.